I'm Jennifer. Good afternoon, everyone. The topic of today's presentation is tracking costs of alternative fuel buses in Florida, Phase 2. Those of you who are regular webcast participants may find this topic familiar. This presentation about the Florida alternative fuel buses was delivered last year. The current presentation describes the continuation of essentially the same analysis, but also features some improved methodology and other useful information. I hope everyone finds something useful in this presentation, and I'll try to keep it relatively concise so we can finish in reasonable time. A little summary of the project is the client for this project was the Florida Department of Transportation. The duration was 18 months and the budget was $90,000. There were main two objectives for this project. First was to continue the process of tracking and reporting the performance and cost of alternative fuel public transit vehicles in Florida using the previously established mechanism, and the second one is research the existing requirements for modifying transit maintenance facilities to make them suitable for service in alternative fuel buses. We were asked to mostly investigate the requirements for compressed natural gas, as there has been a significant interest in that technology recently. A little background about the project to give you a better understanding of the reasons for undertaking it. In the last few years, many transit agencies in the United States and in Florida introduced alternative fuel vehicles into their fleets. The main goals were typically to reduce the fuel consumption and, as a result of realizing fuel cost savings, and also to reduce the greenhouse gas emissions by running a more environmentally friendly fleet. Well, at the federal level, the TIGA grants, which is the Transit Investment and Greenhouse Gas and Energy Reduction Program, that was established as part of the American Recovery and Reinvestment Act of 2009. This program provides funding for acquiring alternative fuel transit vehicles. At the state side, the Florida Department of Transportation also provides help with the alternative fuel vehicle acquisitions. FDOT funds 50% of non-federal share of the bus capital. Well, however, many transit agencies that took advantage of these programs found that these new technologies do not always provide the expected efficiency gains, while often they even lead to increases in both capital and operating costs for the agencies. FDOT already worked with CUTR in the past, trying to evaluate the cost differential between various transit propulsion technologies. In 2007, FDOT funded the development of Bus Fuels Fleet Evaluation tool. It's called Buffett model. That's based on the data on roughly 6,000 transit vehicles and allows the comparison of different alternative propulsion technologies and in terms of their costs and performance. In 2009, FDOT provided funding for establishing a cost reporting system to collect the fleet performance and cost data from the Florida Transit Agency. That project was called Tracking Cost of Alternative Fuel Buses. The current project is Phase 2 of that 2009 project. And FDOT is interested in continuing this effort of collecting the relevant performance and cost data from transit agencies. The new project, this Phase 2, has the following goals: is to continue collecting that relevant cost and performance data from the agencies, and use that data to update the Buffett cost model that was previously funded by FDOT. And then finally, another goal is to continue investigating the specific requirements for modifying transit maintenance facilities to make them suitable for alternative fuel vehicles. We were asked to also pay particular attention to the CNG vehicles, or requirements for the CNG vehicles. The research approach included approaching all fixed route transit agencies in the state with the request to provide data on performance and costs of their fleet. We used the standard data submission reporting tool that was used to collect data, but agencies were also given an option to provide the data in any format that was convenient to them. Agencies were asked to report every calendar quarter on their entire fleet, including the alternative fuel vehicles and the traditional vehicles. We asked to report separately on fixed route and paratransit vehicles. And to facilitate the timely data submission, we sent regular reminders to the agencies and also tried to stay in contact with them over the phone. Also, to investigate the potential modification requirements for maintenance facilities, we reviewed the national and international codes that are applicable to gaseous fuels, and also discussed the experience of the fleets that switched to alternative fuel vehicles to get some anecdotal evidence about that. This is the type of data that was requested from the agencies quarterly. It's, vehicle length, the power plant, fuel type, date placed in service, and so forth. So this is the typical data that most fixed route agencies already collect. In fact, agencies have to report similar data to a national transit database at the federal level. So we didn't ask for anything unusual or extraordinary. From the very beginning, we struggled with a low response rate. Only 9 transit agencies provided data during the entire 2012. So most of the data covered fixed route fleet, and the paratransit data that we could collect was very limited and was incomplete. We also had difficulties with regular reporting. Only 4 agencies provided data regularly every quarter, while the remaining 4 reported just in some quarters. But despite all these difficulties, we were able to assemble the data the data set covering over 2,000 vehicles, which represents the majority of Florida fixed route fleet. These are the 9 agencies that provided the data in 2012. It's Palm Trans, Star Metro, Miami-Dade Transit, Votran, Lee County Transit, Lynx from Orlando, Broward County, Pinellas County, and Pasco County. The agencies were asked to report on the entire fleet, including the traditional and alternative fuel vehicles, so that it would provide us the basis for comparison. Well, here's the characteristics of the fixed route transit fleet that reported to us. 89% of the vehicles were regular diesel buses, and 9% were diesel hybrids. About 2% were gasoline vehicles, and some very few trolleys, and just 1 gasoline hybrid. Basically, there are 2 types of vehicles in the data that we saw. It's diesel vehicles and diesel hybrids. So there is a difference in the size of the vehicle between the 2 types of technologies. Almost 77% of diesel buses were 40-foot buses, about 8% were smaller 35-foot buses, and the largest 60-foot articulated buses constituted only about 1% of the diesel fleet. Well, for the diesel hybrids, it was different. The 60-foot buses accounted for about 1/4 of the hybrid buses fleet, which is the same as the 40-foot bus. Well, since the most complete data is available on diesel and diesel hybrid vehicles, the analysis will mostly focus on the comparison between those 2 types of vehicles. The graphs show the breakdown by the vehicle size and for diesel and hybrid fleet. Well, you can see that while the diesel fleet is dominated by 40-foot buses, the diesel hybrid fleet is more diverse in terms of the vehicle size. The comparison of performance and costs between diesel and diesel hybrid buses, well, regardless of the fleet size, show that the hybrid buses demonstrate about 14.4% better fuel economy, almost 60% lower parts cost per mile, over 61% lower maintenance cost per mile, and at the same time, the hybrid buses cost on average about 67% more than comparable diesel vehicles. The difference in performance, however, can be partially explained by the difference in the average age. You can notice that the hybrid vehicles are typically much younger vehicles than diesel. In summary, the analysis of data indicate that the diesel hybrid buses typically have better gas mileage, the lower cost per mile, but higher acquisition cost. At the same time, the hybrid buses are much younger, with an average age of about 2.3 years compared to over 7 years for the diesel buses. And the hybrid buses are often still under warranty, which can explain the differential in performance as well. The size of the vehicle plays an important role in how diesel buses compare to hybrid buses. What we've noticed from the data is that the differential in gas mileage between the diesel and diesel hybrids is larger for larger size buses. Here's an example. When we look at the 40-foot buses, you can see that the hybrid buses provide 21% better gas mileage, about 63% lower parts cost per mile, and 76% lower maintenance cost per mile. And at the same time, the hybrid buses are also 71% more expensive to purchase. Now compare this to 60-foot articulated buses. The larger hybrid buses provide over 38% better gas mileage, almost 60% lower parts cost per mile, yet they are also show 158% higher maintenance cost per mile. And those larger buses are also 33% more expensive than comparable diesel buses. So the differential in gas mileage is more in favor of hybrid technology for larger buses, although the differential in cost per mile does not necessarily favor the diesel hybrids. One potential flaw in the methodology that's used to calculate the gas mileage and the cost per mile is the use of simple averages. Simple averages ignore the difference in the miles driven and give equal weights to every observation. This may be justified when there are no large differences between the observations. However, in our data, different types of buses vary significantly in terms of the miles driven. As a result, simple averages may skew the results. So in this situation, it may be more appropriate to use the weighted average to calculate the gas mileage and the cost per mile. The idea of using the weighted average is to attach weights in such a way that the parameters that are based on higher mileage will have more influence on the final estimate. Well, here's an example of how the weighted average changes the comparison. Well, as you can see, the accounting for miles driven reduces the comparative advantage of hybrid buses versus diesel. The graphs on the left show the comparison of miles per gallon and cost per mile between the hybrid diesel buses of any size using the weighted approach. While for comparison, the graphs on the right show the same using the simple averages. Well, you can see that when weighted averages are used, the gas mileage for hybrids are practically identical to the miles per gallon showed by the diesel buses. That's 4.48 miles per gallon versus 4.49. Well, that was for buses of all sizes. So now let's take a look at the 40-foot buses, which was one of the most popular buses. For 40-foot bus, the diesel hybrids show even slightly lower miles per gallon than diesel if you use the weighted averages. While the differential in cost per mile is also much smaller when you use that weighted average approach. Well, these findings seemed very strange, but it doesn't mean that we should easily jump to conclusion here. We have to be very careful how we interpret these results. They don't necessarily mean that diesel hybrid buses perform worse than diesel. There are two possible explanations to these results. One is that we have a small number of older generation hybrids in the data set, which are with relatively low fuel efficiency, but which have been in use for some time, so they have logged a lot of miles. And second is that there is a large number of older, higher mileage diesel buses that perform really, really well. They get really high gas mileage. So those two factors combined can produce that result, that the weighted average fuel efficiency of the diesel bus is actually better than the weighted average fuel efficiency of the hybrid bus. But once newer generation hybrids drive more miles, the data will show improved weighted average fuel efficiency of hybrid buses. Well, I just found this observation very peculiar and worth mentioning. Well, I guess the lesson here is that in any research, you have to be very careful how you interpret the data and not just blindly take whatever numbers are thrown at you by the computer. Well, this was not part of the initial analysis. It may be worth looking at the life cycle impact of the alternative fuel transit vehicles. If you extrapolate the differential in fuel efficiency and operating costs that were observed to the 12-year life of the vehicle, well, you can get a rough idea of the magnitude of the benefits. Well, a true life cycle impact analysis is actually much more sophisticated than that, but just doing the extrapolation can give you like a general idea of the magnitude of the impact. So using such extrapolation, we estimate that the diesel hybrid bus of any size will provide an average savings of about $33,000 to a transit agency over its the life of the vehicle, and which will be in terms of reduced fuel and operating costs. Additionally, the use of a hybrid bus instead of a diesel is projected to reduce the tailpipe emission of NOx by almost 1 ton and CO2 by 38.1 tons over the life of the vehicle. Well, while this may not sound like a lot, it certainly is not negligible. Now, the magnitude of a life cycle impact depends on the vehicle size. Well, here are the extrapolated estimates for the most popular 40-foot bus. Well, the data show that replacing a diesel bus with a diesel hybrid is projected to not only reduce tailpipe emission by about 1.2 tons of NOx and almost 54 tons of CO2, but also to provide over $107,000 in savings in terms of fuel and operating cost reduction to the agencies over the life of the vehicle. Well, these are tangible benefits to the agencies that operate those buses, so it's pretty significant. This estimate, by the way, takes into account the costly battery replacement that a hybrid bus will need sometime in its life. We use the estimated value of $67.5 thousand for replacing the battery, and also assume that the price of fuel was $4 a gallon. But as the battery technology improves, lowering the cost of battery replacement or even eliminating the need for one, these potential savings will increase even further. The same is also true if the price of diesel goes up and increases beyond $4 a gallon. So far, we talked about the fixed route buses, but we also requested the data on the paratransit vehicles. Unfortunately, the data on the demand response vehicles that we could collect was very limited. We could only collect the data on 95 demand response vehicles. None of those vehicles run on alternative fuels. So we have that 40% of the vehicles were diesel, 20% were gasoline, and another 20%, the power plant of those other 20% was not known because it was not reported to us. So the data on the paratransit vehicles have significant gaps, and many parameters were missing. So the only comparison that could be done is a very, very general comparison between the two types of fuel used, the diesel and gasoline. So the data show that the diesel demand response vehicles provide roughly 34% better fuel economy and about 19% lower total cost per mile compared to the gasoline vehicles. Also, here's the comparison between those diesel and gasoline demand response vehicles. You can see that the diesel vehicles perform better than gasoline. But that's as much as we can say in the using the data available. So no more meaningful analysis could be performed due to the data limitations. Now let's talk about the second part of this project. In addition to researching the performance and cost of alternative fuel transit vehicles, one of the goals of this project was also to research the modification requirements for maintenance facilities to accommodate the alternative fuel vehicles. In particular, we were asked to review the code requirements for transit maintenance facilities, identify the specific requirements for compressed natural gas and liquefied natural gas vehicles, since these fuels, particularly CNG, is gaining popularity lately. That involved looking at the relevant national and international standards and summarize them in the form of brief guidelines. Most of the information regarding the guidelines for CNG and LNG modifications were taken from the document prepared by the Clean Vehicle Education Foundation that was issued in August of 2012. That report is a very useful resource that gives a rather detailed assessment of the requirements. Well, in this presentation, we can only briefly discuss some of the key aspects of that report. Vehicle maintenance facilities are covered by a number of national and international codes, including the International Fire Code, the International Mechanical Code, International Building Code. Then the National Fire Protection Association has several codes related to the motor fuel dispensing facilities, the Vehicular Gaseous Fuel System Code, the standards for parking structures. These codes apply to all maintenance facilities, regardless of fuel type used, so they deal with both traditional fuels and also provide guidance on handling the alternative fuels. The existing codes were written as performance requirements rather than design standards. As a result, the actual standards for maintenance facilities servicing alternative fuel vehicles are often set by the local authority, local fire marshals, that interpret these codes. Such interpretation may not always be consistent across jurisdictions, so it is prudent to consult the local fire marshal prior to the final design of the facility. Well, another thing to be kept in mind is that the reviewed codes apply only to major repair facilities. The both national and international fire codes exempt minor repair facilities from the code requirements for CNG and LNG. The National Fire Protection Association defines the major repair activities as the work that's involved engine overhaul, painting, body work, any repairs that require the draining vehicle fuel tanks. So big cost savings can be realized if the facility can be divided into the separate major and minor repair areas. But if these areas cannot be separated, the entire facility should comply with the requirements for the major maintenance facility for CNG. These are the 7 areas covered by the codes that apply to CNG and LNG. It's the general ventilation, the ventilation in pits, gas detection system, sources of ignition, electrical classification, and preparation of vehicles for maintenance and decommissioning of containers. Before considering the modifications, though, for CNG and LNG, it may be helpful to verify that the maintenance garage meets the existing code requirements for liquid fuels. The National Fire Code requires a ventilation rate of at least 1 cubic foot per minute per square foot of floor area for the enclosed parking garages that house liquid fuels. So this should be the base rate of ventilation that should be already met by the existing garage. The requirements are different depending whether the CNG is odorized or not. The rules for non-odorized gases are much more stringent. The code requirements address the hazards of CNG by setting the performance criteria to either reduce the presence of flammable mixture or eliminate the potential source of ignition. In this presentation, we'll very briefly review the main areas of code requirements. A more detailed description is available in the final report for this project that can be downloaded from the NCTR website. So these are the following requirements applied to the maintenance garages that handle properly odorized CNG. Ventilation. The National Fire Code has no requirement for ventilation rates that are specific to CNG. So the same ventilation requirement that exists for the liquid fuels will apply to CNG as well. The International Fire Code requires continuous mechanical ventilation of a CNG facility with a ventilation rate of at least 5 air exchanges per hour. This rate can be achieved with a base rate of ventilation of 1 cubic foot per minute per square foot of area when the ceiling height is 12 feet. And when the ceiling height is lower, then you can achieve even higher ventilation rate. Or when the ceiling height is higher, then you'll need a higher ventilation rate than 1 cubic foot per minute to achieve the 5 air exchanges per hour. The operation of the mechanical ventilation is required to be continuous, with some exceptions when the system is either interlocked with the gas detection system or it's electrically interlocked with the lighting circuit. While National Fire Code require the ventilation only for fuel dispensing garages, the international codes require the ventilation of all CNG repair facilities. The main assumption is that the indoor fueling will always be a part of the maintenance operation, so that's why the international code requires the requires this for the entire facility. The ventilation in pits. Ventilation below grade and subfloor work areas is part of the basic requirement for liquid fuels. So this requirement should already be met, and there's no additional requirement for adding CNG. The International Fire Code requires the ventilation rate of 1.5 cubic foot a minute per square foot of floor area, while the National Code requires 1 CFM for the square foot of floor area. You can notice there is some slight discrepancy between the international and national codes, but the exact rate can be specified by the local fire marshal. The gas detection system, well, there are no requirements for the natural gas detection system as long as the CNG is properly authorized. Well, some repair facilities may still decide to install such a system, and if they do, there are some common recommendations for such a system. Well, first, it should be approved by the local fire marshal. It should activate at 25% of the lower flammability limit of the gas, and when it activates, it should basically do 3 things. It should activate mechanical ventilation, deactivate the heating systems, and initiate the audible and visual alarm. And basically, it should do the same 3 things when the system fails. Remember, these are not requirements, but are rather just recommendations or best practices, as long as the gas is odorized. Source of ignition. The International Fire Code, the Mechanical Code, the Building Codes, all of them require restricting the ignition sources from the space 18 inches from the floor. This is a standard requirement for liquid fuels and should already be met by the existing garage. The National Fire Code has additional requirement for CNG garages, restricting the use of open flame heaters, heating equipment with exposed surfaces that have the temperature of higher than 750 degrees Fahrenheit in any area with dangerous concentration of gas. A conservative approach would be to completely eliminate the heating equipment of such type from the garage. Electrical classification. The National Fire Code requires installing the classified wiring in the space within 18 inches of the ceiling of a major CNG garage. Well, there is an exception from this rule for facilities that have ventilation rate of at least 4 air exchanges per hour. The design of the ceiling support structure needs to be taken into account in determining whether the proper ventilation could be achieved in the area directly below the ceiling. If the classified location cannot be eliminated by the ventilation, the options may include either modify electrical installations to meet the appropriate classification requirements, or move all electrical equipment lower than 18 inches from the ceiling. the preparation of vehicles for maintenance. The International Fire Code is the only code that has requirements for preparing the CNG vehicles for maintenance. There are basically two major requirements. The code requires to valve off the old fuel cylinders on the vehicle before entering the repair garage, and in the event of the suspected damage to the fuel system, the entire system should be inspected before the bus is taken inside the facility. Maintenance and decommissioning of fuel containers. The national code, fire code, requires that the repair facilities have specific written procedures for decommissioning fuel cylinders. Each repair garage is recommended or needs to install the proper defueling facility, and there's also a recommendation that the agencies or the garages should consider installing also a natural gas recovery system to reduce the amount of gas that's released in the atmosphere when those cylinders are valved off. These are the requirements for odorized CNG. In the interest of time, we will not discuss the requirements for liquefied natural gas and unauthorized CNG. I'll just mention that the requirements for LNG and unauthorized natural gas are much more stringent. Some things that are just recommended for CNG, especially related to a gas detection system and the ventilation, are requirements for LNG. Now I want to again briefly summarize some of the challenges that we faced with this project. The biggest challenge was related to availability of data. Only 9 fixed route agencies provided some data to us. We also had difficulty with ensuring that the agencies report continuously every quarter. Very few agencies reported continuously and consistently. Some agencies just reported very inconsistently in this quarter or that quarter, but not every quarter. We also found out that in the data reported to us, there was a very small, a relatively small number of alternative fuel vehicles in the transit fleet. We only had 9% of the vehicles that were reported to us were running on alternative fuels, or were considered alternative fuel vehicles. And we also noticed there was a low variety of these alternative fuel technologies used by the agencies. Basically, the diesel hybrid was the only type of the alternative fuel vehicle used by Florida transit agencies. We also, another challenge was that we had practically no usable data on the demand response vehicles. So what we got was just the data on 95 vehicles, and none of them were alternative fuels. The above challenges limited the amount of and reliability of the analysis that could be performed. Therefore, the presented results should be interpreted with caution, keeping in mind that they are based on the limited amount of data. Now I want to say a few words about the next steps in this analysis. We're currently involved in 2 new projects that have similar goals as this project. The first one is the project that looks almost identical to the current project, only it calls for the collection of data and the analysis of performance and cost of the alternative fuel vehicles only at the national level for all transit agencies in the United States. The second one is the project that provides for the establishing the alternative fuel bus clearinghouse that will be used to both collect and disseminate the information on the performance and use of alternative fuel transit vehicles in the United States. We hope that implementing these 2 projects will allow to assemble a bigger, more reliable data set that will include various types of alternative fuel vehicles. As a result, as more field data are collected, the reliability and accuracy of this type of analysis will improve, providing valuable insight to the agencies that are considering to switch from the traditional diesel vehicles to alternative fuels. And with that, I will conclude my presentation. Thank you for your time, and I'll be happy to answer any questions that you may have.
Thank you, Alex. We do have a couple of questions that have come in. Let's see. The first one here is, did you take into account the usage pattern, express versus local, passengers carried, etc.?
We did not take into account the passengers carried, but we did take into account the duty cycle, because the duty cycle was one of the questions in our questionnaire, and obviously the duty cycle actually has a big impact on the performance of especially the hybrid buses. So what we notice is that some of the agencies run the hybrid buses on BRT routes, which they do provide good gas mileage, but the hybrid technology will provide the best performance when it is used in the urban environment with frequent stops, in stop-and-go mode. So because when that is happening, that you would fully take advantage of the regenerative braking. So, but yeah, we noticed that some agencies do not really take the full advantage of all these technologies.
Okay, great, thanks. Another question: how long has the longest in-service hybrid bus been in operations?
I think the longest one that we had was, I believe, it was about 6 or 7 years. So it wasn't. We didn't have really old ones, but the ones that we had, on average, were about 2.3 years. So there were a lot of newer ones, but I believe the oldest one was 6 or 7 years.
Okay, great, thanks. Why do you think your response rate was low? What could be done to increase it and increase the data collected?
Well, that is a good question, because we struggled. It seemed to us that these type of data they should already have, and whenever we try to appeal to the agencies that we explain what we're trying to do. We appeared in front of some of the group meetings that they had. They had the Transit Maintenance Consortium meeting where we made a brief presentation about what we're doing. And during those presentations, we asked them, is this type of data something that you would have? Is this something that's going to be easily collected? I mean, can you give us any ideas how to improve that? And they all agreed that it was fine, that they all have this data, just send it to us, we're going to fill it out. But that's what they said during the presentation. But once we sent it, for some reason, it was really hard to, I understand that somebody has to sit and do it, so they have, I guess, other things that they need to do as well with limited resources. But it was a little disappointing. And to answer your question, I don't know. I don't know how to improve that. Maybe if we do something that's they can do it online, maybe that's going to make it easier for them if we do an online data collection. But that's just a guess.
Okay, great, thanks. How much training is required for technicians when they first received hybrid buses, and has that been figured into the costs?
No, we have not figured that yet. So this was not. We looked at the modifications to the facilities, but not the training requirements. But yes, there is some training that will be needed for the technicians to be able to handle those new technologies. Well, with the hybrid technology, it may not be as significant as with some other ones. Like, for example, if you switch to CNG, that would require completely different skill set. Well, with the hybrid technologies, we noticed that the agencies did say that they had to train their technicians a little bit, but none of them said that it was very significant.
Okay. Do you have any idea yet whether hybrid buses might have longer useful lives than clean diesel?
Anecdotal evidence, yes, we have it anecdotally, but for now, so far, we haven't seen anything in the data. So the data that we have, but once again, this data is very limited. So far, we had very limited number of observations. Plus, the buses that we had, none of the buses, the diesel hybrid buses that we collected data on reached their useful life yet. So none of them were 12 years old. So we couldn't really say whether this claim is true or not. But anecdotally, that's what we hear, that yes, the hybrid technology may be able to extend the useful life of the vehicle. However, we haven't seen that in the data yet.
Okay. Another question that has come in, why were maintenance costs so much higher for diesel hybrids?
Well, I think one of the big thing for the diesel hybrid maintenance is probably the maintenance of the electrical components. Maybe the technicians were not familiar with some of those components, so it required some additional, I don't know, learning curve, and that's how they had to spend some more time learning that. Plus, the big problem was for us in distinguishing how the agencies account for the costs, that the maintenance costs that for those buses, because some of those buses are under warranty, and the agencies count the costs that they have differently. Some of them include the warranty costs, some of them don't include the warranty costs. They just count the out-of-pocket costs. So, I mean, that was a little bit squirrely how the agencies treat those costs.
Okay, well, let's see. Another question is, your data show that hybrid buses provide 14% better gas mileage than diesel buses. This is lower than what manufacturers of the hybrid vehicles typically promise. Can you comment on that?
Yes. We heard different claims from the manufacturers. I mean, typically they claim that the hybrid bus would provide 25 to 30% better gas mileage. Well, these are the claims that I don't know. Maybe the newer buses do provide that. First of all, I need to state that we looked at the overall hybrid fleet. So the hybrid fleet provides the 14% better gas mileage. So it's not maybe the newer buses have 30% improvement, but the older buses have less than that. This is one thing. Then the 14% is the real operating conditions. When the manufacturers come up with those estimates of improvement in gas mileage, they test them in certain ideal conditions that may not always be present when you operate the bus in the real life. And also, as I mentioned, the duty cycle plays an important role. And what we've noticed that some of the agencies do not use those hybrid technologies to fully maximize their potential. Like they don't use them on the urban routes where they can take a full advantage of the regenerative braking, and that would improve the gas mileage.
Okay, great. Thank you, Alex. That's all the questions that we have for today. Oh, actually, one more. Do we know if those who are operating the hybrids are generally happy with them?
So far, we heard, I'll say that, we have not heard big complaints about the hybrids. So I can't tell whether this means that they're happy or they're not just telling us, but we have not heard complaints. But once I need to make it clear, we did not directly ask if they're happy or not.
Right. Okay. Great. Well, I definitely want to thank you for this presentation today. And I'll go ahead and load the evaluation. We have applied for AICP certification maintenance credit for this webcast as well as the recording. So I'd like to thank our audience for their attendance and participation, and I hope you have a great afternoon.